Hello, my dear friends. How are you? I hope everyone is doing good. So, in the previous classes, we discussed about the concept of balancing chemical equation, right? So, in our today's session, let's discuss about the concept of types of chemical reaction. So, in your textbook, they given the types of combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. At lastly, oxidation reaction and reduction reaction. So, in this class, we will discuss about the concept of combination reaction and decomposition reaction. So the first one is combination reaction. First one is combination reaction. So first I will explain some of the examples. So depends upon the examples, can you say what is meant by combination reaction? Okay. So first example is burning of magnesium ribbon. So when you burn the magnesium ribbon, so on that situation, magnesium reacts with oxygen to form magnesium oxide. So that is nothing but 2 Mg plus O2. It gives 2 MgO. Magnesium reacts with oxygen to form magnesium oxide. And the second example is burning of coal. So first one is burning of magnesium, second one is burning of coal. So here coal is nothing but carbon, because coal is a purest form of carbon. That's why here coal is nothing but react with carbon and react with oxygen. It produces carbon dioxide. When the coal is burned in the presence of oxygen, it produces carbon dioxide. So the third example is formation of water from hydrogen and oxygen. So the reaction is 2H2 plus O2, it gives 2H2O. So these are the some of the examples for the combination reaction. The first one is burning of magnesium. When magnesium reacts with oxygen, it forms magnesium oxide. So when the coal is react with oxygen, it produces carbon dioxide. When the hydrogen and oxygen react with each other and form water molecules. So ಇಲ್ಲಿ observe ಮಾಡಿದ್ರೆ reactants are 2, the product is only 1. Correct? So in general, combination reaction is nothing but it is a type of chemical reaction in which 2 or more substances react with each other and produce single product. It is called as combination reaction. So combination reaction is nothing but it is a type of chemical reaction in which 2 or more substances combine together to form single product. It is called as combination reaction. ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು, magnesium oxygen combine to form magnesium oxide, carbon oxygen combine to form carbon dioxide, hydrogen and oxygen combine to form water molecules. So here reactants are 2, but the product is only 1. So in general, the combination reaction is nothing but it is a type of chemical reaction in which 2 or more substances combine together to form single product, or it is a type of chemical reaction in which 2 or more reactants react with each other and produce a single product is called as combination reaction. So the general representation of combination reaction is, A plus B, it produce AB. This is a general representation regarding the combination reaction. The second type of chemical reaction is decomposition reaction. So here the decomposition is exactly opposite to that of combination reaction. So with respect to combination reaction, 2 or more substances combine to form one product. But here decomposition is exactly opposite to that of the combination reaction. It means decomposition reaction is nothing but it is a type of chemical reaction in which the single reactant will break down to form more number of products when the energy is supplied in the form of current, sunlight, or in the form of electricity. So here decomposition reaction is nothing but it is a type of chemical reaction in which one substance will break down to form two or more products when the energy is supplied in the form of sunlight or electricity or in the form of heat. ಸೊ ಈ ಮೂರು ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎನರ್ಜಿ ಸಪ್ಲೈ ಆದಾಗ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಬ್ರೇಕ್ ಡೌನ್ ಆಗಿ ಟೂ ಆರ್ ಮೋರ್ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ದಟ್ ರಿಯಾಕ್ಷನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ decomposition reaction. So here the general representation of decomposition reaction is AB will break down to form A plus B when the energy is supplied in the form of sunlight, electricity, or in the form of heat. This is the general representation of decomposition reaction. So depends upon this type of energy which is supplied to the decomposition reaction. So depends upon that this decomposition reaction is again divided into three types. So the first one is thermolytic decomposition, or it is also called as thermolysis, and the second one is photolytic decomposition. It is also called as photolysis, and the third one is electrolytic decomposition. It is also called as electrolysis. So here, for example, thermolytic or thermolysis. Lysis means breakdown, thermo means heat. So the breakdown of the substances with the help of heat. Photolysis, lysis means breakdown, photo means sunlight. So breakdown of the substances with the help of sunlight is photolysis. Electrolysis, lysis means breakdown, electro means electric current. So breakdown of the substance with the help of electric current is called electrolysis. So let's discuss one by one. So with respect to the type of decomposition reaction, the first one is thermolysis. Thermolysis or thermolytic decomposition. So here thermolysis or thermolytic decomposition is nothing but it is a type of decomposition reaction in which breakdown of the substances takes place with the help of heat. Lysis, breakdown, thermo, heat. The decomposition reaction takes place in the presence of heat is called as thermolysis or thermolytic decomposition. So one of the best example for the thermolytic decomposition is thermolytic decomposition of ferrous sulfate crystals. So thermolytic decomposition of ferrous sulfate crystals, one of the best example. So ಇದೇನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ first you have to take the test tube. So first you have to take the test tube, dry test tube. In this dry test tube you have to take ferrous sulfate crystals. So here you have to take ferrous sulfate crystals, FeSO4 7H2O, ferrous sulfate crystals. Then you have to heat this reactant, or you have to heat this test tube with the help of burner, then there is a formation of bubbles or water droplets on the surface of this test tube. Surface of this test tube. ಏನಕ್ಕೆ ಅಂತಂದ್ರೆ here basically this ferrous sulfate crystals are green in color. These ferrous sulfate crystals are green in color. So when you heat these ferrous sulfate crystals, there is a loss of water molecules takes place. So ಈ water molecules loss ಆಗುತ್ತೆ. ಹೇಗೆ? There is a formation of bubbles on the surface of this test tube. So after that, this ferrous sulfate crystals will changes its color. Changes its color. So basically green ಇದ್ದಿದ್ದು heat ಮಾಡಿದಾಗ there is a loss of water molecules takes place. Because of that loss of water molecules, this green color of the ferrous sulfate will be changed. So ಅದನ್ನ just continuous ಆಗಿ heat ಮಾಡ್ತಾ ಹೋದಾಗ this ferrous sulfate crystals will decomposes to form ferric oxide and sulfur dioxide and sulfur trioxide gas. So when these ferrous sulfate crystals are continuously heated, then that ferrous sulfate will decomposes to form ferric oxide. This is reddish brown in color, and along with that ferric oxide, there is a formation of sulfur dioxide and sulfur trioxide gas. ಈ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನಿಮಗೆ ಕೇಳೋ ಕ್ವಶನ್ ಯಾವುದು ಅಂದ್ರೆ what is the color of ferrous sulfate crystals? That is green. Why the color of the ferrous sulfate crystals will changed when heated? So during the heating process, the water molecules will loss. So for that purpose, the green color of the ferrous sulfate will be changed. So then one more question, what is the color of this ferric oxide? That is nothing but reddish brown in color. So this is one of the example for decomposition reaction. In that adರಲ್ಲಿ thermolytic decomposition. Second best example for thermolytic decomposition is thermolytic decomposition of lead nitrate PbNO3 twice. So this is one of the example for thermolytic decomposition. So in this step, so first you have to take the test tube. So in that test tube you have to take lead nitrate crystals. So in that first you have to take the lead nitrate crystals. Then after the continuous heating of this lead nitrate crystals, there is a liberation of brown color fumes. Okay. So here when the lead nitrate crystals undergo thermal decomposition process, PbNO3 twice. So here this delta is the representation of heating process. So when this lead nitrate crystals undergo thermolytic decomposition, there is a formation of lead oxide and nitrogen dioxide gas along with the evolution of oxygen gas. So here this brown fumes is nothing but evolution of nitrogen dioxide gas. So here during the thermolytic decomposition of lead nitrate, there is a evolution of brown fumes. That brown fumes is nothing but the evolution of nitrogen dioxide gas. Okay. So here basically this lead nitrate is colorless. So when you heat this lead nitrate, it will produce a lead oxide. It is yellow in color, but the brown fumes is nothing but liberation of nitrogen dioxide gas. So ಈ ಒಂದು ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಿಮಗೆ ಕೇಳೋ ಕ್ವಶನ್ ಯಾವುದು ಅಂದ್ರೆ, So one question depends upon the brown fumes. During the thermolytic decomposition of the lead nitrate, there is the evolution of brown fumes. ಸೊ ಹಾಗಾದ್ರೆ ಬ್ರೌನ್ ಫ್ಯೂಮ್ಸ್ ಏನ ಕನ್ಫರ್ಮ್ ಮಾಡುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ದಟ್ ಬ್ರೌನ್ ಫ್ಯೂಮ್ಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಲಿಬರೇಷನ್ ಆರ್ ಎವಲ್ಯೂಷನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್. ಸೊ ಒನ್ ಮೋರ್ ಕ್ವಶನ್ ಯಾವುದು ಅಂದ್ರೆ, ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ನಿಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ. ಸೊ ಯಾವ ತರ ಅಂದ್ರೆ, ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ WPbNO3 twice XPbO plus YNO2 plus ZO2. So in the place of W, X, Y, Z, you have to balance and give the values to each W, X, Y, Z. So ಇದನ್ನ ನೀವು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತಾ ಕೂತ್ರೆ ಟೈಮ್ ತುಂಬಾ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಒಂದು ಶಾರ್ಟ್ ಕಟ್ ಏನಂದ್ರೆ, thermolytic decomposition of lead nitrate 2 2 4 1. 2 2s are 4, 2 2 4 1, 2 2s are 4. ಸೊ ಇಲ್ಲಿ ಯಾವುದು ಇಲ್ಲ ಅಂದ್ರೆ ಒಂದು ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ಇನ್ ದ ಪ್ಲೇಸ್ ಆಫ್ W 2, X 2, Y 4, Z 1, 2 2s are 4, ಲಾಸ್ಟಿಗೆ 1. ದಿಸ್ ಈಸ್ ಅ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ thermolytic decomposition of lead nitrate. And the third example for thermolytic decomposition is thermolytic decomposition of calcium carbonate CaCO3. So when the calcium carbonate undergo thermolytic decomposition, there is a formation of calcium oxide and carbon dioxide gas. So when the calcium carbonate undergo thermolytic decomposition, there is a formation of calcium oxide along with the formation of carbon dioxide gas. So here calcium carbonate, it is also called as limestone, and here calcium oxide, it is also called as quicklime, or generally it is called as lime. So here this calcium oxide is used in the manufacturing of cement. So here the calcium oxide is used in the manufacturing of cement. So here it is complete definition and examples regarding the thermolytic decomposition. So the next decomposition reaction is photolytic decomposition reaction. The next type of decomposition reaction is photolysis. So here lysis means breakdown, photo means sunlight. So photolysis or photolytic decomposition is nothing but it is a type of decomposition reaction. It takes place in the presence of sunlight, or the breakdown of the substances takes place in the presence of sunlight. It is called as photolysis decomposition reaction. So one of the best example for the photolysis decomposition is photolytic decomposition of silver chloride and photolytic decomposition of silver bromide. So here when the silver chloride, so first time ಮಾಡಬೇಕು ಒಂದು ಚೈನಾ ಡಿಶ್. ಸೊ ಈ ಒಂದು ಚೈನಾ ಡಿಶ್ ಅಲ್ಲಿ you have to take the silver chloride crystals. So when this silver chloride crystals exposed to sunlight, it is converted into, or it is break down to form silver and evolution of chlorine gas. So when silver chloride AgCl, when this silver chloride is exposed to sunlight, then it is break down to form Ag plus Cl2. Basically this silver chloride is colorless in nature, colorless or white in nature. Then after that it is converted into gray color. So the gray color is only because of silver. So it is the example of photolytic decomposition of silver chloride. In the same manner, photolytic decomposition of silver bromide. So when the silver bromide is exposed to sunlight, it is break down to form silver and bromine gas. So here also this silver is gray in color. So ಇಲ್ಲಿ ನಿಮಗೆ ಕಲರ್ಸ್ ತುಂಬಾ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿಲ್ವರ್ ಗ್ರೇ ಕಲರ್, ಫೆರಸ್ ಸಲ್ಫೇಟ್ ಗ್ರೀನ್ ಕಲರ್, ಫೆರಿಕ್ ಆಕ್ಸೈಡ್ ರೆಡ್ಡಿಶ್ ಬ್ರೌನ್ ಕಲರ್, ಎವಲ್ಯೂಷನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ದಟ್ ಈಸ್ ಬ್ರೌನ್ ಕಲರ್ ಫ್ಯೂಮ್ಸ್. ಸೊ ಈ ಕಲರ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಹಿಯರ್ these two chemical reactions are used in the these two chemical reactions are used in black and white photography. ನೆನಪಿರಲಿ, last example ಅಲ್ಲಿ calcium oxide is used in the manufacturing of cement. So here these two chemical reactions are used in the black and white photography purposes. Okay, one is electrolysis or electrolytic decomposition process. So here the lysis means, as you know, lysis means breakdown, electro means electricity or electric current. So the breakdown of the substances takes place with the help of electric current is called as electrolysis. So ಒಂದು ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಿಮಗೆ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಇದೆ, that is nothing but electrolysis of water. One of the example is electrolysis of water. So here the reaction is 2H2O. It will break when this water molecules undergo electrolysis. It will break down to form hydrogen along with the formation of oxygen gas. ಇಲ್ಲಿ ನಿಮಗೆ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಇದೆ. ಸೊ ಆ ಡಯಾಗ್ರಾಮ್ 2 ಮಾರ್ಕಿಗೆ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ the diagram shows the electrolysis of water. So ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ first you have to take the plastic mug, then after that you have to insert the carbon electrodes with the help of stoppers, then connect these electrodes to a 6-volt battery, then fill the beaker with water. ಸೊ ಯಾವ ರೀತಿ ವಾಟರ್ ಫಿಲ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಅಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಇಮರ್ಸ್ ಆಗಬೇಕು. ಸೊ ಆಫ್ಟರ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಆಡ್ ಸಮ್ ಡ್ರಾಪ್ಸ್ ಆಫ್ ಡೈಲ್ಯೂಟ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, ಯು ಹ್ಯಾವ್ ಟು ಆಡ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಡೈಲ್ಯೂಟ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್. ದೆನ್ ಆಫ್ಟರ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಇನ್ಸರ್ಟ್ ದ 2 ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಅಪಾನ್ ದ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. ಆ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಮೇಲ್ಭಾಗದಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಇಮರ್ಸ್ 2 ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. ಸೊ ಆಫ್ಟರ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸ್ವಿಚ್ ಆನ್ ದ ಬ್ಯಾಟರಿ and electrolysis process will take place. So during that process, means during the electrolysis of water process, there is a presence of 2 electrodes, that is one cathode and the another one is anode. So in that process there is a liberation of 2 gases. So here the hydrogen gas will be released at the cathode and oxygen gas will be liberated at the anode. ಇದು ನೆನಪಿರಲಿ, ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಎಲ್ಲಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಎಲ್ಲಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ನೆನಪಿರಬೇಕು. ಸೊ ಹಿಯರ್ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ವಿಲ್ ಬಿ ರಿಲೀಸ್ಡ್ ಅಟ್ ದ ಕ್ಯಾಥೋಡ್, ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ವಿಲ್ ಬಿ ರಿಲೀಸ್ಡ್ ಅಟ್ ದ ಆನೋಡ್. ಸೊ ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಹೇಗೆ ಅಂದ್ರೆ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳೋದಾದ್ರೆ, ಕ್ಯಾಥೋಡ್ ಈಸ್ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್, ಆನೋಡ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್, ಕರೆಕ್ಟ್. ಸೊ ಹಿಯರ್ ಆಕ್ಸಿಜನ್ ಚಾರ್ಜಸ್ ಬರೆದಾಗ O2 minus charge, hydrogen H plus, correct. So plus minus plus opposite charges attract each other. So ಇದು ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಒಂದು ಸಿಂಪಲ್ ಟ್ರಿಕ್ ಅಷ್ಟೇ. ಸೊ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ರಿಲೀಸ್ಡ್ ಅಟ್ ಕ್ಯಾಥೋಡ್, ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ರಿಲೀಸ್ಡ್ ಅಟ್ ಆನೋಡ್. ಸೊ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಕ್ವಶನ್ ಏನ್ ಬರ್ಬೋದು ಅಂದ್ರೆ, ವಾಟ್ ಈಸ್ ದ ರೇಷಿಯೋ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಅಂಡ್ ಆಕ್ಸಿಜನ್ ರಿಲೀಸ್ಡ್ ಡ್ಯೂರಿಂಗ್ ದ electrolysis of water? So when the water molecules undergo electrolysis of water, there is a formation of hydrogen and oxygen in the ratio of 2:1. So ಈ ಒಂದು ರೇಷಿಯೋ ಅಲ್ಲಿ ನಮಗೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. So here 2:1. So here when the electrolysis of water, the hydrogen and oxygen will be released in the ratio of 2:1. So this is about the electrolysis of water. So up to here we discussed about the concept of combination reaction and decomposition reaction. So in that decomposition again 3 types: thermolysis, photolysis and electrolysis. ಒಂದು ಟಾಪಿಕ್ ಅಲ್ಲಿ ರೀಸನಿಂಗ್ ಕ್ವಶನ್ಸ್, ದೆನ್ ಡಯಾಗ್ರಾಮ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಅದ್ರ ಜೊತೆಗೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಕ್ಯಾಥೋಡ್, ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಆನೋಡ್ ನೆನಪಿರ್ಬೇಕು. ಓಕೆನಾ?
ಮತ್ತೆ ಭೇಟಿಯಾಗೋಣ. ನಮಸ್ಕಾರ.